Welcome to Notes 7-2 for Integrated Math 3. We're on page 97. Page 97. Let's begin. All right, this is graphing inverse functions. So graphs of inverse functions. Today the learning targets are to graph inverse functions and identify the symmetry. So there's going to be some kind of symmetry that happens. And to use the graphs of inverse functions to determine domain restrictions. All right, the graph of a function and its inverse shows symmetry that arises from the relationship between the domains and the ranges of the functions. So recall that if two functions are inverses, if your original function, right, f of x, has a certain domain and a certain range, then the inverse function, f inverse x, what will happen is the range will become the domain, and the domain will become the range. All right, attend to precision. Find the inverse for f of x equals 3x minus 2. All right, so this is a linear function. I know there will be no restrictions on the domain. So this is a linear function, which implies no restrictions on the domain or the range, always. All right, let's go ahead and find that inverse function. So to find the inverse function, recall we rewrite the function using y instead of f of x. And then we switch x with y. And then we solve for y. And we get that x plus 2 is equal to 3y. And then we would divide. Y equals x plus 2 over 3. And then we rewrite it using the proper notation, f inverse of x equals x plus 2 over 3. There is my inverse function. It says to graph f of x and f prime of x on the coordinate plane. Then graph the function y equals x as a dashed line. Determine the domain and range of f of x and f inverse x. All right, to graph, I would prefer to have my function in slope-intercept form. So I'm going to start off with f of x equals 3x minus 2. Recall that slope-intercept form is y equals mx plus b. And so this function is y equals 3x minus 2, which is already in slope-intercept form. This has a slope of 3 over 1 and a y-intercept of negative 2. So this means it crosses the y-axis at negative 2, so I'll put a dot at negative 2. And the slope from there is going to be either up 3 and right 1, so up and right, or down 3 and left 1, since a negative over negative is still positive, so this would be down and left. So I'm going to go up 3, 1, 2, 3, right 1, up 3, 1, 2, 3, right 1, up 3, 1, 2, 3, right 1, up 3, and right 1. And in the same way, I'm going to go down 3 and left 1, down 3, and left 1, and then I'll sketch my line. So to do that, I'll use some form of a straight edge. And please make sure that you're also using a straight edge when you graph. So let me find a straight edge really quickly. All right. And there's my line, f of x equals 3x minus 2. All right, to sketch my inverse function, as I said, I want this in slope-intercept form. Right now we have it written, something like this, right? Y equals x plus 2 over 3. What I'd like to do is to split this fraction into two separate fractions. So to do that, remember we can write a 1 next to that x. And so this would be y equals, when I divide this is 1/3 x. We're going to leave that a fraction. And then this is 2/3 plus 2/3. Now, if you want to, you could say about 0.66. I prefer to just leave it a fraction. And so this is now my slope-intercept form, where my slope is positive 1/3, and my y-intercept is positive 2/3. Okay. All right, so now to graph this line, I need to go to 2/3 on the y-intercept. So you're just going to estimate it's about right there. And from that point, we're going to move up and right, or we can move down and left. I'm going to move up and right first, which is up 1 over 3, up 1 over 3, up 1 over 3, and then I'll move down 1 and left 3. I should say up 1 and right, but down 1, left 3, down 1, left 3. 1, 2, 3, right there. And again, I'll sketch this line using a straight edge. Okay, so far we have graphed f of x and f inverse of x on the coordinate plane. It says to graph the function y equals x as a dashed line. So to remind you, the line y equals x means that y and x are the same. Or here our slope is 1 and our y-intercept is 0. But I think it's easier to remember that y is just equal to x. So for example, the point -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, and so on. So again, it's the point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. And -1, 1, -2, 2, -3, 3, -4, 4. Or you could, like I said, use a y-intercept of 0, and then up 1 over 1, up 1 over 1, up 1 over 1, and down 1, left 1, down 1, left 1, and so on. All right, so we're going to go ahead and sketch this line in. It says to make it a dashed line, so I will make it a dashed line. And then it says determine the domain and range of both f of x and f inverse of x. So here's f inverse of x. Again, that was 1/3 x plus 2/3. And I did say this in the notes yesterday, but whenever you have a linear function, the domain and the range of both are from -infinity to positive infinity. You can see that there's no restrictions on either one. And so they'll both be functions. This is a line, it will pass the vertical line test. This is a line, it will pass the vertical line test. Again, there's no restrictions to the domain and range of both functions are from -infinity to positive infinity. Or you could say all reals for both. Okay, next. It says to make use of structure, describe the symmetry that you see in the graph from item 2. So do you see any symmetry in this graph? And how would you describe it? What I see in the graph is that these two graphs are reflecting across that line, y equals x. I'll show you what I mean. If I were to, for example, use this point right here, I'm exactly 1 unit diagonally from the line. I'm also 1 unit diagonally from this dashed line again. Over here, if I use, for example, this point, I'm 1, 2.5 units away, and then I'm 1/2, 1, 2 units away. So I see that they are symmetric about the line y equals x. And this symmetry is true for all inverse functions. Okay. All right, let's flip it over and go to the back page. It says you can use the relationship between the domain and the range of functions of a function and its inverse to graph the inverse function. So it says you can use that relationship. What relationship are they referring to? So it's the one I was mentioning before for f of x, right? Whatever the domain is and the range is, if I look at its inverse function, this range will become the domain and this domain will become the range. So that relationship can be used to help us to graph. Okay, it says to graph this function y equals, or f of x equals 1/2 x plus 3, and then determine the domain and range of each. It says complete each step to graph the inverse of y equals 1/2 x plus 3. Okay, so complete the table of values for f of x, then graph the function. So they have graphed it for us, but we will complete the table of values. So to do that, I would substitute in each of these x values into my function f of x. So f of x